Here we're going to look at a couple examples related to quadratic functions, and specifically we are looking at how to analyze a quadratic function and then graph all of its parts. So in this problem we want to be able to find all of these points of interest. So your vertex, intercepts, domain and range, max and min, increase, decrease, as it relates to the function. Now, there are two forms of quadratic functions that we have to pay attention to. The first form is transformation form. And transformation form is essentially your generic form. It says y is equal to a times x minus h squared plus k. And in this form, what you're actually able to do is you are able to just simply pick out all the information you need in order to do all these pieces. Your vertex is formed by the point hk. Your intercepts, of course, deal with your x-axis, and your same with your domain and range. Your max and min values deal with your k value. And then, of course, we have increase and decrease. Now, the other form that we have is called standard form. And standard form is just the normal y is equal to ax squared plus bx plus c. Now, this is the normal form that you should remember from any kind of algebra class, and when you're in this form you have to be able to use what's called your vertex formula. So negative b over 2a and the function at negative b over 2a in order to find your vertex point. Okay? So those are the things that we need to keep in mind when looking at quadratic problems. So if we look at this first one, notice we have negative of x minus 3 squared plus 1. So this is transformation form. So we are looking here So transformation form again allows us to pick all of our information out, and so we're going to just go ahead and start doing just that. The first thing we have to do is find our vertex. So your vertex is the point hk, and if you look, h is a part of your parentheses, k is on the outside. So here we have the point 3, 1. Now I know some students say, wait a second, that's a negative 3, but remember the formula itself is x minus h. In this case, h is positive. Therefore, if I have x minus 3, my 3 is actually positive. The only way to turn this into a negative number is if the sign in here was a plus. So here we've got our vertex form. With that, we also now have our max min value. Now, because my equation is negative, the negative means that my parabola opens down. Therefore, that means that we have a maximum at k equaling 1. We can also use our vertex point in order to state your increasing and decreasing. So increase and decrease is talking about traveling along your x-axis and looking at what is happening with your graph. Are you going up in the positive direction, or are you coming down in the negative? So here if we look at the vertex point, my vertex point is at the point 3, 1. So we can go ahead and put that in. So we're at 1, 2, 3 and up 1. And then we have a maximum. So what that actually means is that my parabola here is pointing down. So when I'm thinking about increase and decrease, if I start at negative infinity and come over here to 3, my graph is actually moving in the upwards location. So I am increasing from negative infinity to 3. Once I hit to 3, I change direction, so I am decreasing from 3 to positive infinity. Now the way that I like to remember that is if you put your pencil on the paper and you move your pencil away from you. So for example, if we put the pencil here and we are moving in an upward position, this is increasing. Okay? Whereas if we put our pencil down and we are pulling towards us or towards the bottom of the paper, this is your decreasing direction. Okay, so moving your pen away from you is increasing, towards you is decreasing. Now the other thing that we can do is we can state our range and we can state our domain. Now this is a quadratic, so that tells you that your domain is going to be all real numbers, which if we list as an interval would go from negative infinity to positive infinity. Our range is going to go down from negative infinity. We're traveling along the y-axis here. Our maximum is here at k equaling 1, so my range stops there. So here we're going to go from negative infinity to 1. Now the only thing that is left is to do our x-intercepts. So in order to do intercepts, we have to do a little solving. So my x-intercept says my y has to be 0, so we have 0 is equal to negative of the x minus 3 squared plus 1. So we simply have to solve for x here. So to do that, we're going to isolate x. So we get negative 1 equals negative of the x minus 3 squared. So we have 1 equals x minus 3 squared. So we end up with plus or minus 1 being x minus 3. Take the square root of both sides. And so here we're going to end up with x is equal to 4 or x is equal to 2. Now your intercepts have to be written in coordinate form. So my intercepts here would be the point 4, 0 and would be the point 2, 0. Now that we have all our pieces, we can graph it. So we've already graphed our vertex. Now let's go ahead and graph our x-intercepts. So we have the point 4, 0 and we have the point 2, 0. And so theoretically that's all we need. Now we can do an additional point if we need it, but basically our graph is going to go like this. Now we have a parabola facing down in the right direction. We have graphed the information that we have. We've identified everything we needed to find, and thus we are finished. Now the only other thing that you could do if you wanted is you could find at least 2 additional points. And the only reason why we say that is because when you graph a parabola, you can do it with a minimum of 3, but 5 points is better. So you could go ahead and find 2 additional points in order to graph. And if we did that, we would find that we have the points 1, negative 3, and we have the points 5, negative 3. And if you look at the way we graph this, you would go over 1, down 1, 2, 3, so pretty much right here. And then we would go over 1, down 1, 2, 3, so right here. And so if you look, my graph essentially hit those points anyway. Alright, now what happens if we are given a form other than transformation form? So here, this form here is our standard form. So standard form means in order to find a vertex, we have to start with the vertex formula. So my point HK is going to be found by using negative b over 2a, and then my function at negative b over 2a. So the first things first is we need to find our h value. So h is negative b over 2a, which is going to be negative of my negative 1 over 2 times 1, which equals 1/2. Now we can find our k, which is going to be my function at 1/2. And so here this is going to be 1/2 squared minus 1/2 minus 6. So when we combine all of that, we're going to end up getting that our k value is negative 25 over 4. So we can start. That tells us that we have a vertex point at the point 1/2 negative 25 over 4. And we can start deducing everything we need from there. So first, we need to look at the max min values. So if we look, my standard form is positive. So this is going to tell us that we have a minimum at k equaling negative 25 over 4. It also tells us that we can identify your increasing and decreasing values. Because we have a minimum, it means my increase and decrease is going to be the exact opposite of what it was in the previous problem. So here we are going to be increasing from 1/2 to positive infinity, and we are going to be decreasing from negative infinity to 1/2. Remember, increase, decrease goes to that x value. Again, we can also look at your domain and your range. Because we're a quadratic, my domain is all real numbers, or as an interval, negative infinity to positive. And my range is going to be the y value, and since it is a minimum, it means we're going to start at the y value and travel up to positive infinity because we are opening up. Last, we can do our intercepts. So here we have 0 is equal to x squared minus x minus 6. So this is going to equal, we can factor this. Once you factor, we'll solve each part. We get that x is equal to 3 and x is equal to negative 2. This gives our intercept values to be the points 3, 0 and negative 2, 0. And then of course the last thing we can look for is any other points that we want to use. And one of the ways that you find that easily is you can go ahead and create yourself an XY table. What that essentially means is you're going to choose x values and solve for y. In this case, if we look at x equaling 1, we're going to end up getting negative 6. And when x equals 2, we get a negative 4. So once we have everything we need, we can go ahead and graph the important information. Now, my vertex, okay, is a little bit complicated to graph. So the first thing I would do is I would graph some of the other information. So I know that I have the coordinate points, or my x-intercepts, to be 3, 0, so 3, 0 and negative 2, 0, so I'd go ahead and put those in. I also found myself a couple other points. So here I have the point 1, negative 6, so 1, 1, 2, 3, 4, 5, and 6. And I have the point 2, negative 4, 2, 1, 2, 3, 4. Now the beauty about these 2 points, in that the fact that we have a quadratic, is whatever point you have on one side of a vertex, you have the identical point on the other. If we look, our vertex is here at 1/2, so I'm at half a point and I'm going to be down, and so I'm going to be down not quite at 7, and so that's kind of your vertex point here. And so if I have a point here that's half away from my vertex, my other point identical is going to be half in the other direction. And then I go 1 point away from that, so I'm going to go 1 point away from this and up a couple, and there is my next one. And so here, in looking at all of those, I now have enough in order to graph my parabola. So we're going to go ahead and we're going to put in your vertex, and we're going to come straight up through our points and point towards the positive direction. Alright, so there you have it. 2 different examples, one using transformation form, one using standard form, both of which are related to quadratic functions. So if you have any questions, please let me know. If you have any examples that you want to go over, or any problems that you're having that you need help with, please let me know that as well. I would be more than happy to go over any additional examples that are needed. Otherwise, I do hope you enjoyed yourself, and I will see you next time.